We want to find the domain of a function from its equation, and the equation includes a radicand that is in rational form. The domain of a function containing a square root includes all values of x for which the radicand is greater than or equal to 0. Therefore, we must solve the inequality radicand greater than or equal to 0. For f of x, this expression is x minus 2, x plus 3 over x plus 1 greater than or equal to 0. And to solve this inequality, we need to create the sign table. The sign table has a row for each one of the factors, the number line from negative infinity to infinity, the zeros of these factors, which are negative 3, negative 1, and 2, and the signs of each factor. X minus 2 is 0 for 2, positive to the right and negative to the left. X plus 3 is 0 for negative 3, positive to the right of its 0 and negative to the left. X plus 1 is 0 for negative 1, positive to the right of its 0 and negative to the left. We now need to find the signs of the complete rational expression, which is the radicand. On the left, 3 negatives give us a negative answer. At x equal to negative 3, negative times 0 divided by a negative is 0. At the interval between negative 3 and negative 1, negative times a positive divided by a negative gives us a positive answer. When x is equal to negative 1, negative times a positive divided by 0 is undefined. Between negative 1 and 2, negative times a positive divided by a positive is a negative. At x equal to 2, 0 divided by a positive divided by times a positive divided by a positive is a 0, and on the right it is a positive. The domain of the rational expressions are the values of x that either create a positive or a 0 quantity. So the domain of f is the interval from negative 3 to negative 1, but it is open at negative 1 because it is undefined for that value of x, union from 2 to infinity. For g of x, we will solve a similar inequality by factoring the numerator and the denominator of the radicand and determining which values of x produce positive or 0 value for the radicand. We have to keep in mind the domain restrictions. Now pause the video and solve, then check your answer. So after we factor the radicand and create the sign table, the areas of the number line that produce positive or 0 value for the expression and indicate the domain are from negative infinity to negative 5 closed, union from negative 2 to 3 open on both ends because these are 0 of the denominator and division by 0 is undefined, union 8 to infinity with the interval closed at 8. To find the domain of h of x, we need to have two domain restrictions. One is that the radicand is going to be greater than or equal to 0. The other is that the denominator is going to be not equal to 0. So the radicand is x plus 4 greater than or equal to 0, and the denominator is x not equal to 0. Now we solve the inequality x greater than or equal to -4, and x different from 0 is already ready for us. And we are now going to graph those solutions. This is the number line from -infinity to infinity. Here is x equal to -4. Greater than or equal to -4 is a closed circle and a shaded right line to the right. X not equal to 0 is an open circle at 0. And the domain of H are the areas of the number line where both the inequality and the difference from 0 are true. And these intervals are from -4 to 0 and then from 0 to infinity. And the domain of H is equal to closed -4, 0 open, union open at 0 to infinity.